Today we are going to talk about getting started with Thick Client Pentest. So today we are going to make sure that you are all set for your next Thick Client assessment and at least know some sort of vulnerabilities that are often found in the Thick Client Pentest. So let's get started. All right, the quick agenda for today would be like just to discuss what are the thick clients, a quick overview, what are the architecture, some common problems that we face while testing the thick client, then looking at like setting up a thick client lab, some vulnerable lab and tools that are often used when we are testing thick clients, some common thick client vulnerabilities, and then we are going to explore and exploit some of these thick client vulnerabilities and at last the summary. So like the agenda looks quite short, but there are a lot of PPTs and a lot of things to cover on. So let's start. All right. So what are the thick clients? You might have heard a lot of names when we refer thick client like Fed clients, rich client, or the desktop application. So all these are the same, and we use them on a very daily. So one common example is the Burp Suite application that we use on a very frequent basis for our regular pen tests. So the desktop application, they may or may not interact with the external API or web server, and some of the common examples are like the proxy tool like Burp Suite, Zap, some web browser like Firefox, Chrome, then computer games like that you have all played like CSGO, some productivity tools, audio and video conferencing tool like the Zoom we are right now using, some diagnostic software for fixing up some of your system's problem. So these are the common examples of the thick client that we use on a regular. So these all are like, just give me a second, please. Yep. Okay, so the thick client architecture. So usually there are two types of application architectures when it comes to thick client. One is your two-tier application and another one is a three-tier application. Now, as the name suggests, in the two-tier application, usually there are two components, the thick client and the database, right? So all the application component when it comes to the two-tier application are either installed and generally they do not interact with any external facing server to process the application logic. So as you can see in this diagram over here, there's a thick client, there's a database, and they all interact on the same local system or a local network. So there is basically, we can say that there is no third party or some interaction that goes outside the network, right? Okay. So the next one is a three-tier application architecture. Now, it involves an application server or an external facing entity to process the certain application logic. As you can see in this particular diagram, there's a thick client, there's an application server, there's a database. So these three interact with each other. And in general, like the communication over HTTP or the HTTP protocol happen. Okay. And the one common example is like the Zoom right now that we are using. So we can see that when we use Zoom, we see a lot of WebSocket communication and things like that. So this is a common example of a three-tier architecture. Okay. So the next one is the proxy aware versus proxy unaware client. So this is a quite interesting thing to understand. That the thick clients are usually of two nature. One where the proxy is natively supported. The common example could be the web browser, Slack, or Teams, where you can simply go plug in your proxy and intercept request, right? Now, from the tester's perspective, it's quite easier to test the proxy aware clients because we can easily listen to the various server interaction requests to the Burp Suite and other tools, right? Okay. So the next one is the proxy unaware clients. Now, these are like always the hard thing. The hard part about them is like they do not natively support any sort of proxying, and it really become a hurdle when it comes to testing them because as a tester, generally it required to tweak a few things, and we will discuss those things later on, that how we can also intercept the traffic when it comes to proxy unaware clients. Okay. Okay. So if you have any questions so far, please feel free to drop the comments and I'll try to pick them up in between. Otherwise, you can also go to the training channel and also start posting your questions over there. All right. Now, the thick client testing methodology. Now, there is no definite methodology when it comes to thick client because there is no standard as such. There is something called OWASP thick client top 10, I guess, which is in the development since the inception. There is no remarkable development that we have seen. So this is my methodology that I usually use when it comes to the thick client pen testing, and some of the other people might also be using the same because more or less like it covers everything, right? So the first part is always the enumeration. And the second part is the client-side attack, network attacks, and the server-side attacks, right? Now, in the enumeration phase, what we usually do is to identify the language, like what is the programming language the thick client is written in, let's say it's Java, Python, .NET, what it is, right? The framework, architecture, are we able to intercept the traffic or not? And at last, like the common functionality probing, where we are like simply going and seeing like, okay, there is a login functionality, there is a registration functionality, there are like, XYZ things, and how we can again, communicate with the various aspect of the thick client. Now, the second one is the thick client side checks. When I say client side, it's not like the input validation check or your traditional cross-site scripting checks that you do in a web application, but it's more on the memory analysis, binary analysis, and some certain checks like that. The next one is the network attacks. Here is the traffic interception and examining the vulnerability on the external server interaction. Let's say your thick client is communicating to a FTP server. Now you are trying to eavesdrop into that communication and trying to steal the credentials. So these are kind of things which are covered in the network attacks. And at last, the server side attacks. So let's say if your thick client is a proxy aware client, which is a 3-tier architecture, right? Let's say, for example, Zoom. There are a lot of WebSocket communication. There are a lot of WebRTC communication that you are trying to intercept and see if you can find some interesting vulnerabilities, right? So in that particular scenario, once you are starting to capture the APIs, most of the checks are same as your OWASP top 10 for web or API, right? So there is no difference, like similar to you do in mobile application. When you start capturing something in Android application or iOS application, everything on that particular part, once you start having everything in your burp suite, is almost same. The only difference is like the initial enumeration and the client side checks. Okay, so the common challenges in the thick client testing. The first one is setting up the correct environment. Each and every time you might need to have a different sort of environment. So for example, in this particular webinar, we are going to focus on the Windows-based thick client application. And let's say if you are testing a Linux-based thick client or a Mac-based thick client, so you might need to have a proper setup. So having a setup as per the requirement of your thick client can be sometimes challengeful and tedious task to do. The second thing is the language understanding. Often we see a lot of different sort of like programming language in which the thick client are written in. The most prominent are the Java, .NET, and the Visual Basic. So if you don't have any familiarity with those applications, you might face some challenge in the initial thing, especially in the client side checks, because a lot of interesting attack vectors, let's say for finding a remote code execution or local privilege escalation or doing some code analysis, actually depend on how you are aware with the particular programming language. Okay. So at last, the traffic interception is the third and the major problem, especially with the proxy unaware clients. And we see a lot of old thick client application that are not proxy aware, and it becomes really a challengeful task to find a way to get the traffic intercepted. And in some scenarios, if your application by any chance is implementing any sort of certificate pinning, so you have to also find a way to bypass that and intercept the traffic. Okay. So the next thing is setting up the thick client lab. Okay. So I have listed some of the tools and the minimum requirement that you should have to basically be able to follow up with this training even after this is ended, so that you can go and practice as well. So the first requirement is having a Windows system. It could be hardware, it could be VM, it could be a cloud instance. For this particular course, I have used Azure-based cloud VM. Okay. So the next one is the vulnerable thick client application. I have used DVTA, damn vulnerable thick client application. If you happen to know anything else, I guess there are 2-3 more vulnerable application. You can definitely go and check them out. And then there are a few recommended tools that you should have in your testing environment, like Burp Suite, Wireshark, then Sysinternal Suite, Echo Mirage, some text editor like Visual Studio Code, and Metasploit framework, Nmap. So strings is a part of this internal suite. So these are a few like basic tool set that you should have in your arsenal to be able to test a Windows thick client application. Now, there could be some other tools based on your requirement. If let's say your thick client is not written, let's say in .NET, so .pic might not be of your use. And if let's say it's in some other language, so you might be willing to use a particular text editor or a particular tool specific to that language for some reverse engineering tasks. So it's always like you have to be flexible and install the tools as you need them. Okay. Now, the common vulnerabilities in the thick client application, some of the names that you see in this particular list, you might find familiar in the mobile application or the web application, and they are, right? So for example, in the sensitive data exposure and the hard-coded credential, in terms of The web application we often see in JavaScript or some other sort of files or endpoints that are revealing sensitive data. In the thick client, we can see sensitive data in registry. We can see in the application memory. We can simply do a strings and see if there are some sort of hard-coded credential or not. So there are, again, like, few nuances where all of these things come together, and like there are very similarities, right? The next one is the DLL hijacking. So DLL hijacking is basically when you are trying to place a malicious dynamic link loading library to the application's execution path and try to gain a priv escalation. So usually it's helpful in the situation. Let's say you are doing an internal network pen test and you encounter a situation where you have a low privilege access in a Windows system, and let's assume that you found an application or a particular service which runs with the elevated privileges, and now you want to find a way to hook into that application and try to again path traversal into, or basically escalate your privileges to have overall access to the system. So this becomes very handy and especially interesting attack in those scenarios. Now, improper error handling, when you are testing the thick client, it might trigger some error on the client side or the server side, and it can give you some sort of verbose information. So that is usually the improper error handling. Based on what sort of database is used, it could be a database injection like SQL injection that we usually see in a web application. It could be the NoSQL injection, etc. Okay. The next one is insecure storage. So often when you run a thick client application, if it's storing the logs or if it's storing any sort of sensitive information, right? So you should definitely check if it's storing the logs or having some sort of sensitive information in the logs or not. So again, this comes in the insecure storage part. The weak cryptography is, let's say it's using some sort of weak functions. Let's say, for example, MD5 or something similar like SHA-1. And if you can potentially exploit them, one common example could be, let's say your thick client is storing the password in a hard-coded form in a MD5 generated hash, or let's say a simple Caesar cipher. So you can try to exploit the weak cryptographic attack against it. Again, there are some more attacks like buffer overflow, code execution, uncoded service path. Improper GUI logics is basically like the kind of visual business logic attacks where you see that some sort of functionalities are disabled, but you are actually do some reverse engineering, able to enable them and do some sort of malicious actions. We will see this in action as well. The next one is insecure file permission. So let's say when you are writing something to a log file, or based on like how your thick client is given the permission, you can also try to escalate your privileges using this sort of attacks. Side channel leakage is basically same as what we see in the web application attacks, where, for example, you found an endpoint where there is a timing difference and you are trying to do for internal SSRF and do a port scan based on timing difference and see if you can perform an attack and find what ports are open. Okay. Similarly, there are more attacks like exploiting a weak public function in use, lack of binary hardening check, codification, sensitive information, application registry, and then there comes the common WASP Web API top 10 check on the Web API request. There's a detailed checklist which covers almost 80 plus test cases and can be found over here. Okay. Now, we will be covering some of these attacks using the DBT, as I mentioned over here, that we will be using this damn vulnerable thick client application. Okay, so first of all, you obviously have to install the DBT application. You can find the binary on this particular GitHub repository. And the second thing is you need to set up the SQL server and FTP so that you can basically connect the database for the user registration and login flow, and set up the FTP, because the DBT application uses FTP for performing some sort of actions. So the author has provided two quick guides. So you can use them and simply go ahead and configure when you are planning to start, testing the DBT in a local environment. The next thing is run the application. And now for the fun part, they have like disabled this configuration button where you actually have to provide the server URL or server's IP or host name so that you can connect to the SQL server and start the application. So just for the fun part, they have like additional challenge, or I can say that the pre-challenge where you have to first enable the configuration button and then simply configure and start hacking. So this is a pre-requirement. So if you are starting or trying to replicate it locally, simply go on to this particular slide and follow these steps and you should be good. Okay. The next one is reverse engineering, enabling the disabled features. Okay, so this is the, as I mentioned over here, this is the challenge where we are trying to enable the configuration button so that we can start attacking the DBT application. Okay, so for this particular task, the reverse engineering, I am using DNSpy because the application is written in .NET and it's easy. So let's go to the demo part. Okay, so let's first of all open this DNSpy and then go to File and load our Thick Client application. In this case, it's DBTA and it's in this particular path. Okay, now scroll down, go to dbta.exe and now go to open this. Now, there are a lot of functions you can see like add expenses, admin, login. So first of all, what we are going to do is we are again first opening the DBT application. Okay, so as you can see that this is the login screen and this configure server button is disabled in the login screen. So this gives us a sort of hint because obviously it's a vulnerable application and getting hints is easier in compared to the traditional application. Let me pause there. Okay, so what we are doing is since we have seen that the config button is disabled on the login screen, I am more interested towards this particular login function. So let's basically open this up and you can see a lot of code written over here. And if we start reading from the line 11, there is a namespace DBTA. And if we scroll all the way down, you can see that this dot is server configured. The message box.show says that application is usable only after configuring the server. And just down on the line 29, we can see that the config server.enabled is set to false, right? So this gives us an idea that we need to make it true to be able to basically enable the configuration button. Let's see how we can do that. So what we are going to do is first of all changing it to the intermediate language so that we can see the various instructions that are being used. So currently it shows for the whole code, but I am more interested into the instruction which can make this false to true. Okay, so let me just fast forward it. Okay, so what I'm doing is selecting this particular this false statement over here and going right clicking on it and going to this edit intermediate language instruction, edit IL instructions. And once you open it, you will see this popped up. And when we go to this line number 18, this idc.i4.0, we are going to make it 1. Okay, and simply click on OK. And you can see that now it's true. Now simply save the module. You will see some error because the app is running already. I'll skip it. Okay, now once you have closed the app, now save again and now relaunch the application. You can see that config server button is now enabled. So this is what I also talked in the improper UI logics attack. So basically they enabled it, they disabled it with the code itself, hard coded itself. And if you go back, you can see that there's no codification implemented. So you can easily understand where the application logic lies, and you can try to find that particular code line or particular module. So in this case, that this config server.enabled was set to false, we simply change it to true by changing the IL action, IL instruction, and we were able to basically bypass this requirement. So this is how you do the reverse engineering with tools like DNSpy. All right, let's move to the next one. Now, since we are done with the more of the pre-requirement, let's go ahead and do a quick walkthrough of the DBT application, because again, this is required because this is what we will be testing. And this is pretty self-explanatory because all the functions are most of the similar that you guys already see in the web application or mobile application pen test, right? There are various features like there is a login screen, there's username, password, you can create your account, config server. I'm logging with an admin privileged user over here. You can see there is something called backup data to FTP server. And then let's try to maybe log in as a normal user or first see the registration screen. You can create a user account by typing the username, password, confirm password, and email ID. Simply click on register. And now let's log in with a valid user account. Once you do that, you will see there are a lot of options like viewing your profile, and you will see the welcome message, adding the expenses. You can save some data in the database, view expense, clear expense, and backup data to Excel. So these are some sort of basic functionality, and there is also something called logout. So there is some sort of attack surface to cover, and this is what we usually do in the visual reconnaissance in our traditional pen test, where we go and traverse the application to see what are the functionalities present in the application, or what are the functions the application has to offer, right? All right, let's move to the next one. Information gathering using the tool called CFF Explorer. So as I mentioned, the very first phase, enumeration, that it's really important to know the architecture of the application or what sort of programming language it is using. And sometimes by looking at the application, I cannot just assume or say that, okay, the application is using, let's say, .NET or Java or something like that. So tools like CFF Explorer really comes handy in such places. Okay. So simply go to the CF Explorer, click on File, Open, and then go to your DBTA binary. Let's open it. Okay. Now, if you see that there are some values populated over here, and by this file type, you can see that this is a portable 32.NET assembly. So this gives an idea that this is a .NET based application. And then there are a lot of other things that you can go and traverse, like DOS headers, NT headers. And then if you go down, like there are .NET directory itself over here. You can check the address converter, dependency walker. So these are the different things that you go and check depending upon like what is something you are looking for. So, but yeah, my purpose to show like the basic information that you can get from here is like sort of programming language it is written on, or the architecture. So if you go to like the different directories, yeah. So if you go to the different directories, let's say for this DOS header, you will see some sort of different values. If you are more interested in writing, let's say a buffer overflow exploit or something, trying to find something similar, these sort of binary machine level instructions are more interesting for you to look at. Okay. So the next one is the viewing the network communication using the TCP view. TCP view is a tool that is natively available with the sysinternal suite, which is again provided by the Microsoft itself. So it's sort of a small toolkit that Microsoft provides. Okay. So I have simply launched this TCP view. And as you can see, there are a lot of communication happening from the various different applications, right? So here the dbta.exe, the process ID, the protocol is TCP. It says like this is established. It's communicating on the local, this localhost right now, because I have configured on the localhost, and it is using this particular port. You can see the remote address, remote port, and when it is created, and different things like that. And you can also use this search button over here for the filtration. I'll just show you. As you can see that I have simply said like dbta.exe, and now I can filter out the specific just for the dbta, right? And if you want to see more, what we can do is we can run a specific action. Let me fast forward it. So right now I have cleared it out. Like let's log in with the username and password, and you can see that as soon as I do some sort of action, there is a new process ID generated for dbta.exe, and we can see some sort of TCP communication happening over there. I'll come back to the Wireshark later on. I would like to cover first some other interesting check, because again, Wireshark is something similar like what you have just seen in the TCP view. It's again, like, let me cover it right now itself. So simply open the Wireshark and start capturing. I am using this particular loopback traffic capture for this one, and perform any sort of action using the DBT application. Let's say, let me reopen the application. Okay, login function. So once you do this login, you will start seeing a lot of things being start to populate over here. I have also saved some data. Now let's stop the capture. So if you see, there are a lot of TCP, TLS version 1 request. You can go to these, click on any of the entry, and then again start to examine them, and you will see some sort of network communication happening that originate from the DBT itself. Okay. So the next one is the compiler protection checks. So The compiler protection checks are basically helpful to protect against certain attacks, be it, let's say, buffer overflows or something like that. So it's really interesting to check if your binary or the thick client application is missing any sort of the compiler protection checks. The process is quite simple. For this, we are using a tool called binscope. It's again provided by Microsoft. So this particular command, the binscope.exe, is to run the tool, and then we are setting it to the verbose mode with the HTML output, and we are saving the file on this particular directory, and this is the target application dbt.exe. So once you run this command, it takes like a fraction of seconds to execute. And it has checked for a lot of things, as we can see over here. Now this is the HTML file generated, and let me pause here. If you see, for this particular thick client, there are no failed checks. And you can see like the various checks were passed, like WX check, VB6 check, or GS check. So now, and you can also see the same list in a separate section called checks executed. And if you go down to the all scanned items here, you can also see all the details of these checks, and you can see the information. So for example, for this DB check, information image is marked at dynamic base compatible, right? So this is again quite helpful and easy to perform task. It takes less than a minute. I have also mentioned the command for your ease, like simply binscope.exe, verbose, HTML, log file, the log file path, and the app path. Okay. This next one is the signature verification check using a tool called SigCheck. Now, the SigCheck is again a part of sysinternal suite. Okay, so let me pause it. So basically, it helps to check if your binary is signed or unsigned or verified or not. So simply run this command called sigcheck.exe and then give the binary path. Okay. Again, it takes a fraction of a second to run, and as you can see that in the verified section, it says unsigned. It means that this particular is not signed by a signature, and then you can also see some sort of information like the publisher, the company name. So these are something that we already know and we have already seen in the initial steps, but the first line, verified unsigned, is of our interest for this one. And if you see some binary is not signed, you can potentially report it if it's definitely not a test application. Okay, the next one is sensitive data exposure, the hard-coded credential. For this, we will be using a tool called string.exe, which to its settings. And then you see this listen on these ports, change this port from native 21 to some other port like 1234 or like 2111 in this case. Go to security settings and click on this disable IP check and click on OK. And now re-enable your FTP server. And you can see that the server is online now. Okay, now we will be using this MITM relay. You can simply Google it, MITM relay. I have also provided the link. First check your IP address. You can see the default gateway is .1 and your IP is .4. Go to the DBT application and provide your IP address. So I'll just skip, this is a basic thing. Okay, now let's launch the burp suite. And go to proxy settings. You can see that it's currently listening to this particular address. Okay, now we will run this simple command, python mitm relay.py. The listening interface is 0.0.0.0, and then we are relaying this. This is really important. The TCP21 is the FTP port, and then this is my system's IP address, and this is the FTP server's new port that we just set initially. And then this P is for proxy, and this is my proxy server's address, which is burpsuite in this case. Once you do that, simply run the command. And you can see that the relay is listening on TCP21 and forwarding it to 10.0.0.4 and to 111. Now set the intercept on in the burpsuite and let's capture some traffic. Now, since it's set for the port 21 specifically in this example, it won't capture your login request. So now once I'm logged in as an admin user, we can see there's an option like backup data to FTP server. Simply click on it. And we can start seeing some responses which are in the FTP messaging format. And you can see that there is a login user DBTS going on. And then it's asking for the password. And then we can see that the password is going on through the proxy. And this is how you can intercept the basic communication that is happening. Okay, so the next one is the DLL hijacking. So DLL means the dynamic link library, and it has a search order. So first of all, it looks for the DLL file in the application directories and goes to current directory. If it's not in the application or current directories, look in the system directory, then 16-bit system directory, Windows directory, and at last the directories that are located in the path environment. So we have a like window of opportunity. Let's say the DLL file is missing. We can try to put it in the application directory and try to do a potential DLL hijacking attack. Okay. So let's see this in action. Now we are using a tool called Process Monitor to first filter out the process dbta.exe and see if we can find some potential candidates for DLL hijacking, like some files that are DLL files that are not in the application execution path. So I'm using this filter option, and then I am setting some condition like the process name is dbta.exe, and then the process result contains name not found, and then the process extension, like the path ends with the DL. So this is the incorrect one. I'll just show you how to add your own. So if you go to this drop down, you can click on the result and then say that the contains, and you can write it. So for example, name not found. Then go to process name. Process name is, as we know exactly, the process name is dbta.exe. And at last, click on this result, the path, and click on ends with, and then just say DLL. These are the three filters that we are most interested in, and it will basically filter out any DLL file that is basically loaded with dbta.exe and having the result as name not found. As you can see over here, there are some particular files in this applications directory. This dbt have been released. So one is this dwrite.dll, then this script sp.dll, script base.dll, and if we go ahead and execute more functions, so I am just trying to perform a login action over here. So if you do a successful login, you will see there are like more DLL files loaded, like secure32.dll, sspicli.dll, and then this encrypt.dll. So these are a few potential DLL hijacking candidates that are of our interest. Okay. So now I have moved to my attacker machine, where I'll run the Metasploit framework to generate a malicious DLL file that I can use for pre-escalation later on. So let's simply run the MSF console. On the same time, back to your Windows machine, make sure that you have the antivirus protections disabled, so that when you download the DLL files, they are not basically terminated themselves when you are downloading it. So I have like turned off real-time protection, cloud delivery protection, temper protection. So this is not my real system, this is a virtual machine, so there is no harm on any data that I have. So once you do that, go to this Metasploit console again, and then we will simply generate a payload using this MSF vnum. Then the payload is this Windows Meterpreter reverse TCP. L host is my attacker machines, and then L port you can set any port of your choice. A is for architecture, which is x86. The F is DLL, and then I am basically creating a dwrite.dll file that we just saw initially, that is missing from the path execution order. Okay, now generate it, and at the same time we will also be like running an Apache server, so that I can download these DLL files from my attacker machine to my victim machine. So simply run this command to start your Apache service. And once you have generated both the DLL files, So this is dwrite.dll, and let's generate secure32.dll as well. Okay, so both the files are now generated. We can simply copy both of these files to our var www.html folder. Let me skip to that particular part. Okay. And at the same time, I have also started a multi-handler. You can simply use a command like use exploit multi-handler to start the handler, and then set the L host same as the your attacker machine's IP address, L port same that you use in the initial payload generation that you can see up here in the command. And then you have to set the same payload as Windows Interpreter reverse TCP. Once you have done that, just leave it as it is. So I am like copying these files to this directory. You can see that these are copied. And then let's go back to the Windows machine and download the DLL files. So as you can see that I have downloaded the dwrite.dll, and similarly we can download the secure32.dll file as well. Okay, so the next part would be to simply rename these files to remove this bracket one from both the files and copy them to your applications directory. I'll simply skip to the part where I've done that. Okay, so it's done over here. Now, once you do that, all you have to do is to basically type the run command on your Metasploit console over here. I am simply now doing run because everything is ready to be exploited. And now move back to your victim machine, Windows machine in this case, dbta.exe. Once you do that, you will observe that your application won't open. Okay, so let me fast forward it a bit. So you will observe that your application won't open because of the malicious DLL file. It may cause some sort of trouble there. And you can see that there is a reverse shell started. So let me just try it again. As you can see that the reverse TCP handler started, sending stage, and the interpreter session opened. And simply I am like now writing the sysinfo command to see if it was successful or not. So as you can see that it's successfully, I have gained the shell on my victim machine from my attacker machine. So this is a simple example of DLL hijacking and how you can, then once you have the interpreter shell, you know the rest, right? When you do the internal network, that you can migrate from one process to another, you can manage a persistent access and can do a lot of suspicious things. Okay. Now the next one is the sensitive data exposure through registry via REST short. There are two different ways to do this. One is to simply go and navigate through all the registry, which is a time-consuming way, and second is a smart way where you can use a tool like REST short. Now what the tool does is it takes a snapshot just before you make any changes. So basically take a first snapshot and then do some action like log into a Thick Client application, then take the second snapshot immediately. Once both are taken, you simply go and compare. So now it gives you less results and it's easier for you to find out basically if there is any sensitive information being disclosed or not. So let's take the first shot from here. And it will take like a minute or two. It's a quite old utility, so sometimes it's like freezes in between. So I'll skip it. Now perform. So first shot is completed. You can perform any sort of login action or some other actions where some sensitive data is basically saved. So I have like simply logged in as a user Harsh and simply click on view profile. And now like take the second shot. And once that is also done, simply click on this compare. Now, once that comparison is done, you will see a HTML file like this, and then we can simply search for DVTA string. You can see there are some sort of 20 results found here. And if we keep on scrolling through the results, we can see that the DBT username Harsh, the password Harsh, and the email h@h.com are basically logged in the registry. Now, you can also verify this using the standard process that we'll see in just a minute. We will be using a tool called regedit. This is again a system utility. And if you go to this computer, HKey current user, DBTA, you will see that there is an email, password, and username disclosed or stored basically. All right. Okay, so the next one is improper error handling. This is again same as we see in our traditional pen test for the web API mobile, that any malicious task that you do that triggers a verbose error message revealing some internal information is something the improper error handling is. Sometimes the information could be just like, basic library information or a SQL query or something like that. And sometimes it can also give you interesting credential or more wide information. So I'm going to this debug release where I haven't properly set the server URL. So as you can see that this config server is disabled because I haven't performed any action on this particular debug release. Now type any gibberish credential like test and any random password. It freezes sometimes, so I'll just skip to the next part. It sometimes freezes like this. And then you can see that there's an error popped up where you can see the unhandled exception. You can see something mentioned about SQL. And when you go to this details tab, you will see some queries in the exception test field. So this is how you also check for the improper error handling. And it's again same as the web application. You can type in different combination. You can type some gibberish content, special characters, and see if you can trigger a malicious behavior and result in an improper error handling attack. Okay. So the next one is SQL injection to perform authentication bypass. This is the test application. So the payload like username, code, or x equals to y minus minus plus works. So let's see this in action. This is a pretty basic example. So what I'm trying to do is I'm trying to log in as an admin user. So simply let's do admin code or x equals to y and minus minus plus anything gibberish in the password field. And we can see that we are successfully logged in as the admin user. Definitely, you won't find that sort of easy SQL injections unless it's a very basic or actually a test application. But in general, this is how you go about testing for authentication attacks as well using. And these again comes somewhere related to your traditional web and API attacks. Like because generally in these functionalities, if it's a three-tier architecture, we are able to intercept the request and see the various communication. We can start like fuzzing for various attacks like SQL injection and whatsoever is applicable, right? All right, so that's quickly it for today. I hope to take on more vulnerabilities in the following part. There are a lot of interesting stuff that we can definitely discuss on and talk about, like buffer overflows, some more advanced attack vectors, doing some traffic interception with the invisible proxying and stuff like that. And these are a few tools that we have used today, and you can simply go to these links and download. I know that most of the tools you are like already familiar with. And if you have any questions, this is the time. And once again, thank you. And also, I would like to call out Nilesh and Manish for reviewing the presentation. Thanks for that.